Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on air and combustion. We are going to focus today on fractional distillation of air. Previously, we discussed on rusting. We looked at how rusting occurs, what causes rusting, what are some of the things that accelerates rusting, and also we looked at ways of preventing rusting. So today we are going to be starting on how to obtain oxygen, and there are two ways. There is the industrial process, and there is also a preparation of oxygen in the laboratory. So today we are going to look at the industrial process known as fractional distillation of liquefied air. First of all, we know that air is a mixture of gases. This means that air contains different constituents in itself, and these constituents can be separated by physical means. These physical means are examples like boiling. You're also going to see filtration. These methods are usually physical in their nature, so these things can be separated by these means. They can't be separated by chemical means, but physical means. And this process is usually divided into two main stages. The first stage is the purification and liquefaction, and there is the fractional distillation of air. We are going to look at the details in a minute, so let's look at that. So first of all, this is the process, the large-scale process. So we are going to start with air. So first of all, let's look at the components that are in air. So some of the components of air we have is nitrogen, oxygen, carbon dioxide, dust particles, water, and argon, especially in the noble gases. Argon is the one that is of the highest content. We know the largest percentage is nitrogen, being at 78%. And we know like components like dust particles and water are dependent on the location. They vary depending on the also season. So we talked about the components of air. So how do we separate them? We separate them by fractional distillation of air. So let's look at each and every step and each and every component that is being removed. So this air, which contains these constituents, is first passed through the filters. In the filters, the dust particles are usually removed by a method called electrostatic precipitation. So there are some electrostatics are used to attract the dust particles, which causes them to be attached to the filter. And so the air that is gets out of this filtration chamber is usually dust-free. So this dust-free air is taken to another chamber containing sodium hydroxide solution in concentration or potassium hydroxide. So the sodium hydroxide and potassium hydroxide can be used interchangeably. Both of them function by absorbing carbon dioxide. So when sodium hydroxide reacts with carbon dioxide, it usually forms sodium carbonate, and when potassium hydroxide reacts with carbon dioxide, it also forms potassium carbonate. So if we look at the components of air that we are remaining with, we have already removed the dust particles, we have removed carbon dioxide, so we have been left with nitrogen, oxygen, water, and argon. So the next part, the carbon dioxide free air, is taken to the coolers, where it's cooled at temperatures -1 or -25. So at -25°C, the water turns into ice, and any carbon dioxide that was to be removed in the previous chamber that has not been removed will also be solidified in this chamber and removed as well as solid. So we know that carbon dioxide, also commonly known as dry ice, also forms solid directly from gaseous state. Is one of the compounds that sublimes or also undergoes the process of deposition. So also ice, which is comes from the water, will also form. We usually remove the ice and carbon dioxide before taking them into the compressor, because we do not want them to go to the compressor where the temperatures are even lower. If that happens, it means they are going to turn into solid form and they are going to block the pipe. And if they block the pipe, it means that they are going to stop the reaction from occurring the way it's supposed to occur. And of course, it has some economical issues. So now when we look at the components that we are remaining with, we have also removed water because we have removed it by cooling. So we are left with nitrogen, oxygen, and argon. This is the remaining part of air that is taken to the compressor. And in the compressor, it's usually compressed at 200 atmospheres. And also it's cooled at -200 degrees Celsius. There is a continuous expansion and contraction that happens in this chamber that causes the remaining part of air to turn into a liquid. That is where the name comes from, fractional distillation of liquefied air. So this remaining part of air, that is nitrogen, oxygen, and argon, turns into a liquid, and then this liquid is fed into the fractional distillation chamber. If you can remember, we talked about fractional distillation when we were talking about simple classification of substances. And we said that fractional distillation is used to separate miscible liquids that have close but different boiling points. So in this case, the liquid air contains oxygen in liquid state, argon in liquid state, and nitrogen in liquid state. And all of these solutions are miscible, but they have different boiling points. So this liquid air is heated slowly. After it's heated slowly, nitrogen is the first to be distilled off because it has the lowest temperatures, followed by argon, and then followed by oxygen. So there is a bit of confusion that usually happens when we look at the negative values. So we are going to go back to a little bit of math and discuss why -196 degrees Celsius is lower than -183. If you look at a normal number line, in mathematics, we said that the values that are on the right hand side are positive and their amount is increasing gradually as you move to the right. So that's why we will say +1 is smaller than +3. +3 is very big in comparison to +2 and 1. The same which is slightly different applies with values that are on the left side of the number line, which are negative. So these numbers usually decrease as you move to the left. So we say -1 is bigger than -3. As you go to the left, the negative values are becoming smaller and smaller. So if you look at our temperatures of the solutions that are being distilled off, we see that nitrogen is -196, argon is -186, and oxygen is -183. You notice that -196 is further and further away in the negative side in comparison to argon and oxygen. Oxygen is actually having a boiling point that is closer to the right side of the number line. So that's why we say nitrogen, which is -196, has the lowest boiling point and will be collected off as the first, and then the one that is closer to that or follows it is argon, and then finally oxygen is collected as the last constituent. So I hope you've understood. Let's look at one question. So oxygen is obtained on large scale by fractional distillation of air as shown in the chart below. So we have the chart. You can see air passing through filtration and purification. Then it is compressed and expanded until it turns into liquid air, which is fed into the fractional distillation chamber. And in the fractional distillation chamber, the different components are able to be extracted depending on their boiling points. So let's look at the question. Question 1, explain why air is considered a mixture. So we said air is considered a mixture because it contains different constituents that can be separated by physical means. So that is what we said. Let's go to the next question. Identify the substance that is removed in the filtration stage. So the substance that is being removed at the filtration stage, from the word filtration, it tells us that it is the dust particles. We said that they are removed by electrostatic precipitation. Let's go to the next question. Explain why carbon dioxide and water are removed before liquefaction. We said they are removed before liquefaction because when they solidify, they block the pipes. And if they block the pipes, when we know that this reaction is not going to continue because the other part of air is not going to be moved into the other apparatus. And then finally, identify the component that is collected at negative 186 degrees Celsius. We know that the component that is negative 183 is our oxygen. Since if you look at the three temperatures, it is actually the highest. So we know that oxygen is the one that is collected the last. And then the one that is in between is negative 186, which is our argon. And finally, negative 196, which is our nitrogen. And we have an acronym to help you to remember on how they are collected. So we start with, it's called NOW. There is nitrogen, argon, and oxygen. So this is negative 196, negative 186, and negative 183. So those are the temperatures. So that brings us to the end of this session. I hope you have been able to connect and understand the fractional distillation of liquefied air. Next, we are going to be looking at how we prepare oxygen in the lab. So stay tuned for that. Have a good day.